Alright, hello once again, Jeff Scott of Rankin Technical College, and I've been going over a series of video presentations I'm doing for the Rankin Technical College AWD1100 C# programming language class, and in particular from our book, Xerox C# 2015. I'm in the object-oriented programming section, and I have done lectures on chapters 12, redid them, and did 14, and I've done one lecture on chapter 15 talking about interfaces. Now we're going to move on to generics. Oops. There we go. All right. You use generics to define a type-safe collection that can accept elements of any type. In other words, it's kind of a catch-all. Typically, you put T here, and that's able to handle any kind of variable there is. All right. If you want to define a class for a generic collection, you code those angle brackets after the name of the class, as is shown right here. And you specify the type parameter within these brackets. Then within the class, you can use that type parameter anywhere that a data type might be used. For example, you can use it as a return type or a parameter type. By convention, as shown here, most programmers use the letter T as the type parameter for most classes, but you can basically use whatever you like. Now, the generic custom list class works like the generic collection class that was described way back in Chapter 8. The output of what you see here on screen assumes that the product class includes a toString method that will display the product code, the description, and the price. So to get that, you'll need to override the toString method. Now, the .NET framework contains or defines many generic interfaces. These are particularly useful for working with classes that define generic types of collections. All right, here's one shown here, the iComparable, which compares objects of type T. As I mentioned to you before, if the two objects are equal, 0 is returned. If the first object is greater than the second, 1 is returned. If the first object is less than the second, -1 is returned. And here are some additional ones. There's iEnumerable, which gets an enumerator of type T for the collection. iCollection, which provides basic properties for an enumerable collection. There's iList, which manages a basic list of objects. And there's iDictionary, which manages a collection of key value pairs, which is what a dictionary is. Now, there's an example on page 497 of the book and right here of how you use the iComparable interface. All right, and again, as mentioned on here, I'm not going to say it to you again. If 0 is returned, they're equal. If a negative number is returned, the first is less than the second. If a positive number is returned, normally it's -1, 0, and +1. It is possible something else could be returned. And finally, constraints. When you define a generic class, you can use constraints to restrict the data types that your generic class accepts. And as you can see, this is the chart from page 499. Those words include class, where the type argument has to be a class. That should make sense. Struct, where the type argument must be a structure. And new, where the type argument must have a default constructor. On pages 500 and 501, you are shown a class that implements the IEnumerable interface. There's a for each loop, as you'll notice in the middle here. It only works on generic collections that implement the IEnumerable interface. All right. As a result, if you want to use a for each loop on a generic collection that you've defined, you must implement IEnumerable. Okay. When implementing the getEnumerator method, you can use the yield keyword with the return keyword to return the current element of the object it implements. On pages 502 and 503, the author shows you how to code an interface that uses generics. All right. When you define an interface, you can use generics just as you do when you define a class that uses generics. When you implement a generic interface that you've defined, you can specify the type of argument the same way that you do when you implement generic interfaces from the .NET framework. We're not going to do a whole heck of a lot more with those other than that. All right. That pretty much gets us to the end of the road for this chapter. I'm not going to present right now any additional information from here. All right. I'm going to look at my notes and see if I've got anything that looks worth presenting, and if I find it, I will do so. All right. So the chapter that we have left then from this section is Chapter 16 on how to organize and document your classes. You'll notice there's only 17 PowerPoints, so there's not a lot in here. So I'm going to come back and finish that one off in just a couple minutes.